Hello student, in this lecture we are going to start steady state analysis of the control system. So first of all we are going to discuss steady state error. This steady state error is very important topic in control system. So see here, steady state error is nothing but the value of error signal when t tends to infinity. T means time tends to infinity. So it will measure the accuracy of the system. So this steady state error is used to measure basically the accuracy of the system. Okay. Generally, this steady state error is due to nature of input or type of input or nonlinearity of the system component. You are going to get this type of error. Okay. Generally, what is meant by this error? Basically, what is meant by error? What do you mean by error? So see, error means if your actual output is not matching your input, then the difference between those, that means between those means output and input. So error means if our actual output is not matching our input, then the difference between those two are known as the error signal. Okay. Now we can analyze the signal. We will get an equation for the signal. See, generally we can observe in this block diagram, RS is our input, CS is the output for this closed loop control system. Okay. Here we are having open loop gain is GS, and here we are having a feedback gain HS of this control system, and this is the negative feedback control system we consider here. Okay. So now here if we observe the error signal ES, so this ES is equal to RS minus CS into HS. Okay. Or otherwise this ES can be found by this equation. So see the equation. We know the transfer function of this closed loop control system is CS by RS, and this CS by RS is equivalent to GS divided by 1 plus GSHS. Okay. Again, this open loop gain GS is equivalent to CS by ES. We can write this GS equal to CS by ES. From this, CS equal to ES into GS. Okay. So putting this CS in our first equation, that means transfer function equation, that means CS by RS. Okay. So if we put this CS value in CS by RS, then we get this equation ES into GS divided by RS, and this is equivalent to GS divided by 1 plus GS into HS. Okay. So after simplifying this equation, we get ES equal to RS divided by 1 plus GS into HS. Okay. So now from this equation, how we will get ET? Okay. That means here this ES, that means this error signal is in frequency domain. So if we want time domain of this error signal, okay, so as this is Laplace transform, so we need to consider this is frequency domain. Okay, so this ES in the frequency domain, this error signal is in the frequency domain. So if we want time domain of this error signal, as this is in the Laplace transform, so we need to consider inverse Laplace transform to get time domain of this error signal. Okay. So see here we need to consider inverse Laplace transform of ES to get time domain of this error signal. Okay, and that is represented by small et, and this small et is equivalent to inverse Laplace transform of ES, and this is equivalent to inverse Laplace transform and put the value of ES. Okay, so see, so what is meant by steady state error? So steady state error is the value of error signal when t tends to infinity. We got the error signal et. Et, that means we got the error signal in time domain. So steady state error is the value of error signal at t tends to infinity. So limit t tends to infinity, et is nothing but the steady state error. Okay, so according to the definition, if we got error signal, then the value of error signal at t tends to infinity will be steady state error. Okay, so we see the equation of steady state error. Okay, so this is the equation of steady state error. S's represent steady state error. Okay, so S's is steady state and E represent error. So steady state error is the error signal at t tends to infinity. Okay, so this is the formula of steady state error. Okay, so see, if ES is given, so to get ET, again we need to considering inverse Laplace transform, and after that we need to substitute t tends to infinity and all this. Okay, so I am going to use final value theorem here. So see, this steady state error, that is ESS, is equal to limit t tends to infinity et. Okay, so see, this steady state error is nothing but the final value of the signal. So how we will get final value of the signal? We will get final value of the signal ESS is equal to limit S tends to 0 SES. Okay, here I have given this formula. So according to final value theorem, we can write steady state error ESS is equal to limit S tends to 0 SES. Now onwards we can write this steady state error is equal to limit S tends to 0 SES. Okay, so we can write steady state error like this according to final value theorem. Okay, so if given ET, then by substitute t tends to infinity, we can find steady state error. Or if give ES, then just by taking final value of that ES, final value of error transform, that means limit S tends to 0 SES, we will give the steady state error. So in this lecture I have defined steady state error or I have derived how we calculate steady state error. Okay, so thank you student. Hope you people understood this lecture.